Yeah, thanks on everyone. Let's start off. Okay. Hope everyone is able to hear my voice. My voice is clear. Okay, great. Then I think I might have a little lag, but yeah, it should be fine. Chalo, other scams on. So last thing that we are doing was this A is equal to minus KV. This is what we did. Hope everyone has gone through the logarithms ka video also. That should have made things little clear now. Great. Let's go ahead with one problem. And then acceleration of a particle, a bar. So now we are doing the same thing, integration, but this time in vectors. Is let's say given by T I cap plus J cap. Initial velocity is U bar, which is 2I plus J. Initial position, I'll call it R initial, is minus 3I plus 2J. Find the velocity vector V bar as function of time t and the position vector R bar as function of time t. Let's get this. So last time when we did this in 1D. We are doing the same stuff, but we are doing it in vectors now. Hope you remember the formulas like A bar is dV bar by dt. So we'll send dt that side and we'll get dV bar is equal to integral A
You have
dt.
a pencil? No.
Right? So yeah, give it a try. It's a double integration. We will wrap up this thing, I think, in the first half of the class. We will start off with then kinematics today. We're almost at the end of calculus, and this is actually the beginning of kinematics, you can say. Others, you need to keep your cams on. Anish, Priya, Samana. You got an answer? You can type in the chat box here to the co-host. Let's give it a try. Okay, we have one answer, I guess. Okay, let's see. So acceleration is t I cap plus j cap. This can be written as dv by dt. dv bar will be t dt I cap. So the integration will be just a regular integration except for this j and I. So integral 0 to time. Now here you can have limits as a vectors also, u bar and b bar. So since the left hand side you're integrating a vector, you will get the limits as vectors. On the right side, time is a scalar, so limits will be time. So when you integrate this, limits will be v bar, limits will go from u bar to v bar. What is u bar? This guy. We'll write it down later on. This would be t square by 2, 0 to t, I cap. This is t, 0 to t, j cap. This will be v bar minus u bar is equal to t square by 2 I cap plus t, j cap. Then you get a v bar is equal to u bar. And what is u bar? I'll just shift it that side, which is 2i plus j. Then bring all I caps together and j caps together. Check. That's your velocity. Any doubts on this? Please ask me. So the limits, right? They really don't care. It should not need not be a number every time. It could be a vector also. The integration is simply telling you you're going from where to where. Now, what do you want? Position vector. What is v bar? dr by dt. That's it. You just have to be careful with that. So t square by 2 plus 2 I cap plus. This would be t square by 2 plus 2 dt. I'm going to skip a step and integrate directly. So you can check it out. T plus 1 dt j cap. Again, limits. This will go to r initial to r final. This will go from 0 to time and 0 to time. This will be r final minus r initial. What is r initial? That's also given. Minus 3i plus 2j. On the right hand side, t square dt will be t cube by 3, that is 6 there, plus 2t I cap t square by 2 plus t j cap. Yeah, it's little lengthy, but it's not tough. So don't get confused between a lengthy question and a tough question, and bring all I caps together. T cube by 6 plus 2t minus 3. Tick. That's your answer. Please verify your answer. Someone is not clear with this, please ask me. Any doubts on this? All clear with this? Radhika, Dave, Karthik, Anish, Sumana, clear? Yukti, Tanmay, Yukti, clear with this? Shrikant, Cloak. Great. Let's see one more like this. Acceleration is given by sine 2t I cap cos 2t j cap. At t0, your velocity vector is 0. Find velocity as function of time t. Then I can ask you position also, but yeah, this is fine. Is my voice coming? Yeah. Hmm. It's long. Anish, check your answer again. Yeah, there is one part generally people goof up. So hmm. That looks right through. Anyone else? We have one answer. Uh, cos ax plus b is 1 by a. Hmm. These are the two formulas. Okay, let's see. So acceleration is dv by dt. It is given initially it is 0. This is v bar. This is 0 to t and 0 to t. So on the left hand side, we'll get a v bar, and this would be minus 1 by 2 cos 2t, 0 to t I cap, plus this would be 1 by 2 sine 2t. Another common mistake is here. Cos 0 is not 0. Cos 0 is 1. That is a mistake people do. Like, that's it. Not a not a tough thing, but happens in a flow, right? When you're in a hurry, people do that mistake. So this would be cos 2t, and when you put cos 0, in j cap. So your final answer would look something like this. Half into 1 minus cos 2t I cap. There. All clear with that? Clear, na, Radhika? Shreya? Clear? Manav? Clear? All clear with this? Now let's see one more like this, but I'll ask you in a little different way. Let's say we have a resistor. You studied in school. Let the resistance ka value is 10 ohms. Through the resistor, let's say charge q is flowing. So the small q is the charge flowing through the resistor. And we also studied in school, the flow of charge is nothing but current. And this charge q is given by t square minus t, where t is time. Right? Now, few things you will need this information. Current I is given by dq by dt. Means if you differentiate this, you will get current. If you guys remember, the power produced in a resistor, heat, is given by integral I square r dt. Power into time. I square r is the power. So these are the two informations they are given. So if you differentiate, you will get current. And if you have to integrate I square r dt, that will give you heat. So using all this information that is given, find heat produced in 2 seconds. Now later on in 12th, right, this will be taught. So then they will not give you this. They'll expect you to know these two equations. But for now, you can use them. There, this is another way of asking. Every time it won't be velocity, acceleration, and position. They can play with other stuff also. So charge is given, and heat is given as integral I square r dt. I is the current. Okay, we have one answer. So in case you're still confused like how to start, differentiate it. You'll get the current and take it and put in this Hitka formula there. So this thing involves one differentiation and one integration. At your level, this would be a kind of a paragraph question. Right, Sumana. We have two answers. Anyone else? We have three answers. Yeah, I think people are getting it. Right, Rohit. Finish off solving. I'll give another 20, 30 seconds. Okay, let's see. So this is the charge. So current I is dq by dt, which is 2t minus 1. There I got the current. Heat is integral I square r dt. You want for 2 seconds, so limits will go from 0 to 2. This will be 2t minus 1 ka whole square, r is 10 and dt from 0. Take the 10 outside. Integral, this guy would be 4t square minus 4t plus 1 dt from 0. Okay. Integrate this. I'm going to skip some steps. So 10, that would be 4t cubed by 3 minus 4t square by 2 plus t. Limits will go from 0 to 2. That would be 4 by 3. 2 cube is 8. That is 2 into 2 square plus 2. That's 32 by 3 minus 8 plus 2. That is minus 6. 6 3 is 18. 18 minus 32, 140 by 3 joules. That is the heat produced. Yeah. All clear with this? Again, not really tough, but the wordings, right? Suddenly you see the word resistor, heat, current, it scares you. So if you see actually we did really nothing new. So that you have to be careful, and advanced people have this habit of doing it every time. They do this. Even in yesterday's paper, it was the same thing. Most of the questions were doable, but the wording and the language and you see the picture, right? People get scared. So, like I keep saying, step one is what? When you see a question, what is step one? Don't panic, right? Because see, and if you panic, you should think this way. Okay, if I am panicking, that means most of the people in the country are panicking, right? And that's a good thing. So then you have to say to yourself, okay, let me calm down then. Because if everyone is going to panic, the one who panics least is the one who's going to perform well. Getting it? So it is that way. When you're playing tennis, if there are two newbies, okay, new amateur players playing tennis, who is the one who wins more? The one who does less mistakes. It's not about your skill at that point. When you're amateur, right? When you're really not a superstar player or something, between two newbies, right? The one who does less mistakes wins. As simple as that. And when you're a pro, right? And then that's a different game you're playing. So that depends on how many times you played well in an under pressure situation because they won't do normal silly mistakes. Anyway, that is one. So there we have seen some models there. So that is how you can use integration and differentiation. Now, other than this, in physics, right, we have a one more level of integration, integration with substitution. You do encounter them, right? So whenever they come, I'll show you again, but let me show you those three models now. This is more of a max. You should know them because by the time max people teach you integration, it will be next year. It will be too late by then. But we are going to use this a lot. We will use it today only in the kinematics chapter. So it's called integration by substitution. So this is the technique to solve. Just like, you have a tool, like a screwdriver, like a hammer. This is just a tool. Physics may, it will come in some way. So let's see the variations in this. So in this also we have two variations. For example, if you see an integration like this, integral x square plus a square into x dx. Now there is no general formula that I taught you for this. And let's say a is constant. So how do we integrate like this? So this is what the technique that we use. Put x square plus a square is equal to t square. So this is called integration by substitution. You're substituting that whole thing with a new variable called t. Differentiate on both sides. X square का differential will be 2x dx. A square का differential will be 0. Right side का differential will be 2t dt. You might be thinking, okay, sir, you're differentiating with respect to what? Okay, you can differentiate with dt and you can send dt that side. You can think of like that also. It works. Perfect. Then you got everything. So we got x into dx is equal to t into dt. Now substitute everything in that integral there. So your integral will become, see how your integral becomes. Integral root over x square plus a square. That guy becomes t square. X into dx becomes t into dt. Did you see how it modified? Right? So it becomes pretty straightforward. Maybe I'll write down the whole thing again. So root over x square plus a square into x dx will transform into root over t square and integral t dt. This simply becomes t into dt, which is t squared dt. And this integration is nothing but t cubed by 3. But what is t? T is this guy. Substitute back again, you end up with x square plus a square whole power 3 by 2 by 3. That is your integration of x square plus a square into x dx. This technique, right, is called integration substitution. The basic identity that I gave, no, I didn't do anything like that. Not sure what you learned. But is this idea clear, everyone? Don't worry too much about it. No need to write it down. Just have an idea. ऐसा भी कुछ है. Because whenever this thing comes, I will tell you. Right? And don't worry too much about it. Because when Max may, they will actually teach you the integration. This will look like a joke. Right? But have an idea. This is how you should solve. Like, I'll show you one more variation of that. That I think you can write it down. We will need that. Same thing. Suppose if I have to integrate integral x dx by root over x square plus a square. So how do you know you have to put this thing? I think, that comes from just a feeling like, if you see, right, whenever I differentiate this, I will get x dx and that becomes t dt so that I can eliminate this. I think you should just see that and figure it out. Like, if you ask me, sir, how do you know? I will simply say my max teacher has taught me. So, right, it's a max class, so we'll not get into that. Like I said, physics may luckily, right, there are only 3 integrations which you need to know. So we will do the same story here. Again, see, nothing changed. Put x square plus a square is equal to dt. And now your integration becomes x dx becomes t dt. Root over x square becomes t square. That becomes simply integral dt, which is t, which is root over x square plus a square. Easy? Any doubts on that? If you want, you can do one thing. You can note down this result, but if it comes again, I'll tell you to derive from scratch. So, because I'll tell you what is the advantage for this. Because if you remember the result, tomorrow, you know what I will do? I will say this is x square plus whole square power 5 by 2. I can still do the same thing, right? Nothing will change. सिर्फ कहाँ पे change होगा? Instead of this, it will become t power 5 by 2 or something. So it is still integrable. You're getting it? So the idea is whenever you see that x square plus a square and you see x dx, substitute it. That's the idea there. This is one integration of substitution. This is one technique there. Hello. Yeah. Able to hear me now? Yes. So maybe it'll come 4 to 5 times. That is the thing. Let's see one more. The second variation, integral dx by root over a square minus x square. This is another form here. So put x is equal to a sine theta. Y. You will see again when you put this, you'll see something interesting there. So differentiate on both sides, we get dx. A sine ka differential is cos theta, d theta. Substitute everything here. This 1 second. I think this is lagging a bit. Hmm. Yeah. Now it is better. Able to hear me, right? Yeah. A square minus sine square theta. This would become integral d theta, which is theta. So what is this integral exactly? But what is theta here? We can clearly see sine theta is equal to x by a. Theta is sine inverse x by a. So if you replace that, we get dx by root over a square minus x square is sine inverse x by a. Plus constant because I'm not putting any limits here. Clear with this? This is the second type. You can note it down. This also does come a lot, especially in a chapter called SHM and oscillations and waves. So that's where you will see this a lot. Any doubts on this? Well, let's see the third form. Integral dx by root over x square plus a square. You put here x is equal to a tan theta. Do you guys remember the tan ka differential? A is x square theta, d theta. That's your tan ka differential. That when you substitute here, you end up with a is x square theta d theta by denominator becomes A square tan square theta plus a square. That becomes 1 by a d theta. That would be 1 by a tan inverse x by a plus constant. That's it. These are the three integrations you should know. More than remembering, right? Have an idea like when to use when. Meaning, I can give you a little clue kind of thing here. See, look at here. Why did I use here sine and not tan? Think about it. A square minus x square. So under the root, this function should be always positive number, isn't it? So x square ka value can't be more than a square. Now, if you see, right, that means sine and cos functions will work here. This will work with sine or cos. Here, denominator, you have no problem. If you put sine or cos here, you will get 1 plus sine square theta. Can I do anything with that? No, right? So 1 plus tan square theta works. Even cot theta works. So yeah, that's the rough idea you should know. Like, oh, that is how I simplify it. All clear with this? That's about our integration. I think for now, you guys need to know this integration. We will use this. You can copy it down, but yeah. When it comes, I want you to derive it rather using the result directly. Yeah. Okay, let's go ahead. Okay, able to hear me, right? Let's go ahead. So there, we are starting the new chapter, kinematics. So officially, like you can say, vectors and calculus, right, are still mostly math only. So kinematics is our first physics chapter. You can think of like that. Yeah, but yeah, we did a lot of physics so far. Let's go ahead. What is kinematics? It's a study of motion without inquiring about the cause of the motion. So meaning we are not going to ask, when I say the body is having velocity 10 meter per second, uh, we're not going to ask, okay, how did you get the 10 meter per second? Like, how did you get the acceleration? So those questions will not be asking here in this chapter. We will deal with that in the next chapter, laws of motion. Clear? Great. Now, how do you know something is moving? So if I ask you this, is Mount Everest moving? Is Mount Everest moving? It depends. What if you're standing on moon? If you're standing on moon, then the Mount Everest is moving. If you're standing on the earth, it is not moving. Right. Always say disturbance వస్తుంది. Yeah, right. So we need to define something. So we cannot say like, something is moving or not. It's completely depending on the frame. So we need to define a reference. Inertial frame. This is important, like in physics, right? Depending on the frame, you can see different things, and you're not wrong. It's like asking this question: is killing someone good thing or a bad thing? See, now the question comes: who is killing whom exactly? A soldier is killing a terrorist. Good thing or a bad thing? Now you'll think like, that is okay. That is okay, right? Someone just comes to the school, takes a gun, and starts shooting everyone, especially the physics teacher. So, and good thing or bad thing? Like, not at all a good thing, right? So that is the thing. It depends. Frame of reference, right? It's all about that. Yeah. Voice is clear, right? Is it only Anish having an issue? Yeah. Okay. I don't know. I think he's the only one who keeps messaging. No props. Happens. So let's see what is this. So I keep telling them this, it always depends on the reference frame. Like winners are always right. Right. And the reason is because not because they're right, because winners get to choose right in history, isn't it? Who writes the history? The winners. Just imagine, okay, World War II, instead of Britain and US, right? Hitler had won the war. What would be written in those books? The great savior Hitler has saved the world from the tyranny of the British Empire. British was occupied half of the world and was terrorizing colonies, and Hitler came and saved us from the slavery. And that is how the story would have been written, isn't it? Obviously, because the entire history would be written by Germans, and Hitler would be the god. So yeah, unfortunately, that's how things work. Now going ahead. So what is inertial frame exactly? This is another problem there. So it is your choice. It's a reference frame about which observations are done. As simple as that. Any frame from where you're doing the observations is your inertial frame. You can choose anything as a reference frame. You can take Sun as a reference frame. You can take Mars as a reference frame. Just think about it. Imagine we send some people to Mars. They occupy the Mars colony, right? And maybe after 200 years, people are being born there and brought up there, and you ask them, what is your home planet? What will they say? Mars. They don't even know who the hell is Earth. For them, Earth is an alien planet. Getting it? So it's always like that. So for what we do, since most of the time we stay on Earth, we take Earth as a reference frame. So we will keep our life simple. For convenience, we choose Earth as a reference frame. So tomorrow, if humans start colonizing the entire, solar system, let's say people are staying on Mars and maybe Jupiter and asteroids or something, then maybe we can take Sun as a reference frame. Because for all of us, Sun looks like a center point. We can use that as a reference for navigations. Right? We can choose anything as reference frame. There is nothing like that. Because in universe there is nothing at absolute rest. Yeah, but once you say it's a reference, stick to it. Then we also define something called as non-inertial. But I'm saying for our level, we will always stick to Earth as a reference frame. So we will talk about more about this in the next chapter, but roughly a little idea. So what is a non-inertial frame? So any frame accelerating with respect to The inertial frame. So you choose a frame and you do observations from there. Now, with respect to that frame, you see something accelerating. Then we call it's a non-inertial frame, and we have problems with this. Newton's second law starts failing in this frame. Newton's laws are not applicable. So you have to be careful in non-inertial frame. Yeah, so that's a little thing there. So even before studying about motion, right, you need to define where are you seeing things from. All clear with this? Now, how do you decide something is moving or not moving? Can I turn the page? It's all theory there, right? But any doubts? Great. So, how do you decide something is moving? If the coordinates change with respect to time, the body is said to be moving. They're pretty straightforward. If your coordinates are not changing with time, it's not moving. Coordinates are changing, it's moving. Yeah. Then we will define few things here. The position vector, you guys already know that, but I think we'll directly go to the distance. So what is distance? Distance is simply the length of the path traveled by a body between 2 points. Or you can say between initial and the final. So if you're going from A to B, since you can go from A to B in infinite ways, there are infinite paths. So if someone asks you what is the distance traveled, the first question is, what is your path? If you don't tell me how you traveled, I can't tell you how much is the distance. So this is path one, let's say this is path two, and this is path three, and so on. I can create a number of paths. There are infinite distances between 2 points. So whenever they ask you distance, it becomes important. What is your path? That's a very simplistic definition. Now, mathematically, how do we get distance? So if someone asks you to calculate distance, the only formula you know was what speed into time. But what if speed is changing? So this is how you calculate distance mathematically. There are two possibilities. Case one, a straightforward formula. Distance is integral mod v bar dt. Simple thing. Because what is mod v bar? Speed. What is v bar? Velocity. If you put a mod across it, it becomes speed. And if your speed is changing, how do we integrate? We take the speed, we take a small time, isn't it? We multiply with that small time and then we keep adding it. And that's what we call as integration. That's it. So integral mod vdt is speed. So use this formula if v is given in terms of time. We will see questions on this, but that's a straightforward formula there. Case two. Now, sometimes you'll get a path. Let's say it is going like this, some random path, and they ask you find that distance here. So what we do, consider a small section here at ds, right? The small path. I'll exaggerate this. So it will not look like a straight line if you zoom in, right? It's so small, d theta. This is ds, this is dy, and this is dx. Is that making sense what I did? I took a very small path. I just zoomed in for you to see. Since it is so small, can I treat it like a straight line? That's the whole point of integration, isn't it? When you take something so small, you can treat it like a straight line. Now, using Pythagoras theorem, I can write ds is nothing but root over dx square plus dy square. Take out dx common, you end up with root over 1 plus dy by dx whole square. Now, if I integrate on both the sides, this becomes the length of the curve or the distance. If you add all this, ye chota chota ds, 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 if I add all the small things, what do you think I'll get? I'll get the total length of the path, isn't it? Length of the path or distance is integral ds, which is nothing but integral 1 plus dy by dx ka whole square into dx. You can also write this thing as, if you guys remember, what is 1 plus dy by dx whole square? This is 1 plus slope ka square into dx. So if you know the slope of the curve, I can use this. So when to use this? Use this if velocity or equation of the curve is given. If you know x and y, we can, and the relation between them, you can use this. Use this if equation of the curve is given. You can note it down, note down this stuff, like just the main formulas you can remember. You can just note down this thing and this thing. Yeah, these two are sufficient. The things which are circled, those things you can just note it down to the side. Clear with this? Great. So that's about distance. You can see, right? Distance looks pretty silly, but it is actually the most deadliest one. You want distance, there is no direct way to do stuff. You have to go through integration, or you literally have to somehow figure out the path. Next thing, displacement. This is straightforward. This is a vector from initial to final position. We have done this extensively in vectors. So bx, by, bz. This is your OA bar. O B bar, A B bar. So if you are going from A to B, this is simply B bar minus A bar. Displacement will be integral V bar dt. Did you see? There is no mod. Just putting that mod and removing the mod changes the whole answer. So V bar is your velocity. Just a small theoretical thing. Distance is always greater than equal to displacement. What is wrong with this? There is something wrong with this. Oh, what do you guys think? I have to put a mod first because displacement is a vector, distance is a scalar. You can't compare them. What you can compare is the magnitude of displacement, right? Not a big thing, but yeah, happens. Like mathematically, it's not right. So okay with this. So then we are going to play with the distance and displacement today. Take a break. Come back by 9:35. We'll continue from here. Any doubt so far? Great. Come back by 9:35 then.
Sir, I had one doubt.
So let's start off. Camps on you. Let's go ahead with the question. So we got a regular hexagon. Yeah. Not sure why it started updating. This is weird. Okay. So we got a regular hexagon of side A. This is 3A by 4, and this is A by 4. Okay, not exactly in the middle, it is at 1/4 and 3/4. So an ant goes from A to B, and then it goes from B to C. So it's traveling this way. So this is a regular hexagonal plate. An ant walks from A to B to C. Simple thing. Find distance and displacement. Let's get this. It's all geometry there, nothing calculus, no hi-fi, no big deal. But let's see. In case someone don't remember about an hexagon, we did discuss this in basic max. Let me show you a little about hexagon properties. Where did we do that? Here. This was a thing about hexagon. Say. A regular hexagon has all sides equal. It is made of 6 equilateral triangles, and all angles are 60 degrees here. So that's the first time you have seen in basic math and vector. So yeah. Let's see how do we get this. The ant goes from A to B, and B is not the midpoint. B is at 1/4 and 3/4, and B to C. C is the midpoint. Find the distance and the displacement. The distance is the length of the red line, and displacement will be this black line, isn't it? Because displacement doesn't care how you travel. It's only initial and final. Try. I'll give you 2 minutes. Let's see what do you get. Yeah. Others do keep your cams on. Any answers? Shrikant, Yukti, Kamson, Karthik. How do we do this? Hmm. Okay. If someone is lagging, just leave me a message. Okay, let's see. Maybe you can think of, maybe you can use some easy ways, but when I see this question, this is what I think of normally. So from here to here, if I join a line, right? Remember this length is 2a. This length of this green line is 2a, right? That is a by 4. And remember this angle, 60 degrees. Agreed? I can use cosine rule. So let's call this point D. So in the triangle ABD, right, I can use cos 60, which is nothing but the AD square plus DB square minus AB square is 2 times AD plus DB. Remember the cosine rule? Right? I know everything here. I know AD is 2A. I know DB is A by 4. And yeah, AB is what you need to find. I think you'll get it from there. Great. Then for the other part, I'm not going to calculate that. So you guys can figure it out. See if you can actually do something more easy also. I don't think so. I can't think of anything else. Yeah, if you found an easier way, let me know. The other one was B is here. Now you want to go to the C, the midpoint. So again, you want to find this length. So yeah, the idea is always to make a triangle. So I can join from mm, B to C. I think getting coordinates is also one way you can do that actually. That might be easy actually. Getting coordinates would be easier, I guess. Let's see. I just made up the numbers like yeah. See, take this as origin 0 comma 0. Okay. This would be a comma 0. Agreed? This would be how much? This is 60 degrees and this side is a. So this would be 3a by 2 comma 0 because this would be a cos 60 and this would be a sin 60. Perfect. That means this point of coordinates are 3a by 2 comma root 3a by 2. This angle is again 60 degrees. Agreed? That's again 60 degrees. How much was this length then? That will be 3a by 4 cos 60. This is 3a by 4 sin 60. So B ka coordinates will be 3a by 2 and you're going backward. 3a by 2 minus 3a by 4 cos 60, comma 3 root 3a by 2 plus 3a by 4 sin 60. Yeah, I think this is better maybe. So cos 60 is how much again? That's half. That is 3a by 8. That is 4, 3, 12 minus 3. So I think that's 9a by 8, comma. Take out root 3a by 2, 3a by 4, and root 3 by 2. If you take root 3a by 2 common, you end up with 7 by 4. 7 root 3a by 8. That's the bigger coordinate. Clear? I can do the same thing for the this thing. This is luckily the midpoint, so I can go backward. I can do the same argument here. This coordinates will be minus a by 2, comma root 3a by 2. This would be 60 degrees and this would be a by 2. So C ka coordinates would be, this would be a by 4 and this would be a by 2 sin 60. Yeah, numbers are a little bad, but yeah, can be done. So this coordinates would be minus a by 4, comma root 3 a by 2, 1 plus half, 3 root 3 a by 8. Hmm. 3 root 3 by 4. There, that's your C ka coordinates. All clear with this? And then I think you can get whatever you want. So it is just lengthy. So you can do then A to B plus B to C. That's your distance. You know how to use the distance formula. Displacement is A to C and you're done. I will leave it to you. This was also fine, but this thing ke liye, I could have D to B was still easy. If I make this, I won't get a triangle. It's becoming a little mess. So yeah, it's okay. Clear with this? There's nothing too much to think. It is just like, see if you can figure out some other easy way, then let me know. But if this is fine, it is fine. This is the thing I can think of as of now. Let's see something better. Next thing. No, before starting this question, let me explain you something. If you take a rectangle of height h, and if you draw a diagonal, now if you take this rectangle and fold it into a cylinder, you can do this with an A4 sheet and check it out. You'll get a cylinder. If you take a rectangle and fold it, it becomes a cylinder where the height of the cylinder will be h. If you take the cylindrical radius to be r, you will notice this will be 2 pi r. Is that making sense? Because if I take this thing, if I mark this in green, the circumference also will be green, isn't it? So the length of a rectangle becomes the circumference of a cylinder and the height becomes this thing. And if you look at this red line actually becomes a curve. This is called a helix. Where you have seen an helix before? Ever seen screw cut threading? If you ever see a screw, the threadings of a screw is actually a helix. This is the helix. So this is how you can represent a helix. It's a rectangle ka diagonal. When you fold it into a cylinder, it becomes a helix. So this is the threads on a screw. Or a bottle cap. We have done something like this before also. If you remember in basic maths or vectors, I guess we did this in vectors. Yeah, not here. I was teaching you about polar coordinates and all that stuff. Uh, did we do somewhere? Yeah, this question, yeah. If you look at the fan inside your lift, when the fan is rotating and the lift is going up, how does the particle actually go? Just imagine, look at the fan on your, just imagine the fan inside your lift. How does the fan go in a circle? How does the lift go? Straight line? If you combine a straight line and a circle, what do you get? A helix. Is that making sense? It will just keep going up and up and up. So we did find the coordinates. The fan is rotating and then we played all these things. So yeah, we did all that stuff. So something similar. So there. Got a little background? So how do you get a helix? To get a better picture, it would look something of this sort. There. There, if you mark this point here, the one would be somewhere here, two would be here, three is here, four is here, five, six, seven, eight, nine. You're getting how the points are. Able to visualize this picture there? So if you just round it up, right? If you open it up, this is how you will find the helix. So you can see it forms the diagonal for a rectangle. If you make a rectangle, it forms a diagonal. All clear with the story? Now there, I explained you what is a helix. Now the question. So we the starting point is A and the ending point is B. So you left a small bead here, maybe a ring or something like, a bead. You know what's a bead? Oh, hota hai na? Like it is just, what is a bead, right? So, the Rudraksha kind of thing. So a bead, or you can say ring, whatever you want to call, however you're comfortable. So a bead slides along the helix from A to B. Yeah, but to do this, you need to know what is a helix. So I need to tell you all that story. Find distance and displacement when the bead goes from A to B. One turn helix, huh? This is a one turn helix. Now I have 4.5 turns, and how will you divide that? The end of the story is simple. If I open this, this will become a diagonal of a rectangle whose height is h. But is the base still 2 pi r? That's the thing you need to ask yourself. And think. I'll give a minute or two. It's a good one. That is how the questions will be. No one will give you a question where you have already seen before, or you can just see and calculate. You have to figure it out. And physics, that is the thing. You see the question, you feel like you understood everything, but then you keep scratching your head like, what the hell? But in this, the displacement was the easiest one. You should have got that at least. Distance is a tough one. Displacement is the easiest one, isn't it? Anish did get something. Okay. That looks right, Anish. Others try. Did everyone get the displacement? What is displacement? Initial and the final point, right? So you don't care about helix and all that. You just draw a line. What is this height? H. What is this thing? 2r. So what is the displacement? Root over h square plus 4r square. That's your displacement, isn't it? That's it. One single step. That's your displacement. There's no need to think about displacement. Displacement is a good person, actually. Distance is the rogue guy who always messed up. You have to put some effort. That looks right, Karthik. Right, Anish. I think we have two answers. Others, try. I'll give another 30 seconds, 40 seconds. Don't worry about the question, okay? Think about like how can I put this on a rectangle like a diagonal? I'll help you. I think you're getting confused. No, see, the end of the story was this. If I open the helix, it will form a diagonal of a rectangle. Great. What are the dimensions of the rectangle? Let's start from there. Height of the rectangle is h. This does not change. But tell me one thing. Was this entire height for only one single helix? Single turn? Nay, right? This whole height is divided for 4.5 turns, isn't it? That means, think of like this. This will still be the diagonal. That is right. So, for the first 2 pi r, this will be your one turn, isn't it? This is your first turn. So after every turn, you will travel 2 pi r horizontally. This is 2 pi r. This is 2 pi r. This is 2 pi r. And the last thing is an half turn, so that will be pi r. Can I say like this? For every one turn, horizontally, you'll keep traveling 2 pi r, 2 pi r, and 2 pi r. So this is your second turn. This is your third turn, and so on. So from this logic, you can clearly see the base will be 4.5 times the circumference 2 pi r. Is that understood? So one turn will give you 2 pi r. If you have 4.5 turns, it will give you 4.5 times 2 pi r. Yeah. Look at the picture there. This will help you to visualize, isn't it? Look at this each section here. Isn't this each section 2 pi r? It's like each is 5, isn't it? You can divide the height also into a cylinder. So where is A? A is here. Where is B? B is here. If you make it a straight line. So now you're done. What is the distance? Root over h square plus 9 pi r whole square. Any doubts on this? Please ask me everyone. Understood how I made a rectangle? And why is the base 9 pi r? Everyone convinced with that? Rohit? Shlok? Yukti? Convinced? Ananya? Dave? Dave? Sure? Hello, Dave? Able to hear me?
Yes, sir, I'm able to hear you.
Yeah, clear, na? Okay. So what about the displacement? So 1, 2, 3, 4, and 5, right? So the displacement, this was A, and this was B. I need to find this directly here. This was 2R, and this was H. And so the displacement was actually the easy one. Root over H square plus 4R square. All clear with the helix? Clear? Let's see one more. You guys remember this? We did this in foundation. We did this thing in basic math also. But I think let's do one more. There are some of you are new. We got a cone. Radius R. L is the slanting length. We have a point here, A. So we got an ant here, which goes around the cone and comes back to the midpoint here, B. You're getting how is this cone going? The cone is walking on the outer surface. The ant is walking on the outer surface of the cone. It walks around it and comes back to B, which is on this line. Right? It comes back to B, the midpoint. And from B, it walks again and comes back to A. So that's how this ant is walking. Find the distance traveled. An ant starts from A, goes around the cone. Wait, I have to tell you something more. Goes around the cone to reach B, which is a midpoint of O A. This tip is O, and comes back to A along the line BA. Find BA, right? The speed of the ant is, let's say, 1 meter per second. Find a path which takes a minimum time. Find the minimum time for the ant to come back to A. Or let me keep it simple. Find the minimum distance. Or wait, I'll make it more simple. Yeah, midpoint of it. Hmm. Find the minimum distance. Yeah, I can add all those additional things, but I think this is the crux of the problem. Let me brief you a little more like what is happening. Tell me one thing. When the ant is going, it can go like this. It can go like this. It can go like this. It can go any way to it, right? There are infinite ways the ant can go from A to B. Do you guys agree with that? There is not a single path. There are infinite ways. You just have to go around the cone. So I can go like this, then I can go to B. I can go like this, I can go to B. I can go here, I can come to B. I can go here, I can go to B. Can you see? There are infinite ways you can go from A to B. Among all these ways, there is only one path which is the shortest. Find that length. Is my question clear, everyone? Simpler? Let's get this thing. If you got this, all the things I was trying to add, you could have done. So let's not hit our head there. Let's figure it out. This we did in our basic max in a different way, but there I think in basic max the question was this: the ant goes around and comes back to A. Let's see how we do this thing. Anyone not clear with the picture, didn't understand the question, please ask me. Yeah, meaning for people who have seen this thing before, you know what to do. For others who are new, it might be little effort. So think, take a minute. Take a minute, and then I'll show you the solution what we did there, and then I'll give another minute for you to think. So if you understood how to start, maybe you would have got it. So, hmm. So what is the problem in these kind of things? In school, we studied this thing. The shortest distance between 2 points is a straight line. Remember? On a plane, there is an extra word. On a plane, on a flat surface, if there are 2 points, the shortest distance is a straight line. But now, unfortunately, our ant is walking on a cone, which is 3D structure. We are unable to understand how the hell it is even walking also. So what if I can make it a plane? You will get only in terms of variables. So yeah, you can leave it like that. So how to make it a plane? See, take the cone. This was point A. This was point B. Take a scissor and cut it here. If I open this, what shape do you think I'll get? If we take a cone and cut it till point O here, and if I open this, what shape do you think we'll get? We will get a sector. Everyone agrees with that? This is also B. This is also B. Is this making sense? Now tell me, you want to go from where to where? You want to go from this A to this B, isn't it? Isn't that the shortest path? Any doubts on this? So now when you fold it back, you get a cone. When you open it, you get a flat surface. Now, can I argue like, okay, since it is the shortest path on a flat surface, shouldn't it be the shortest path on a curve also? Is this logic clear, everyone? And here I know what is this length? This length is L. I know this length also, L by 2. And what about this angle, theta? Any ideas how to get theta there? If you take this angle to be theta, can someone tell me what will be this length here? The one I'm marking in green?
2 pi r.
Isn't that? Yeah, that is this length, isn't it? 2 pi r. Sure. And from here, can I get angle theta? Theta angle is nothing but arc length, which is 2 pi r by L. Didn't I get my theta? For a sector, this L will be the radius and 2 pi r will be the arc length. So the theta will be 2 pi r by L. Any doubts on this? And then you're done. So basically now you got a triangle OAB. I know cos theta, which is in variables. That must be OB square plus OA square minus AB square. I can use my cosine rule. 2 times OB plus OA. I hope you can see all the things I taught you in basic maths, right? How they're popping up. And then you know everything here. So yeah, theta, you can leave it like that. We get AB square is equal to OB square, which is L square plus L square by 4 minus 2 times L square cos theta. That would be AB is equal to L into root over pi by 4 minus cos theta. That's your answer. And theta is this. If numbers are given, you could have substituted it. Is this clear, have? This is how you handle 3D shapes. So in case you want a little more on this, you should definitely go back to, yeah, this was the, I think we did the same question there. Yeah, we did the same question. I thought we did something else. But I think I gave numbers here. So yeah. Oh, we did the same question. I thought we did easier version. But okay, you got it. It is a good one. All clear with this? Let's see one more. R bar, position vector of a particle. R bar is given by t square by 2 I cap plus t cube by 3 j cap. T is time. Find distance traveled in 2 seconds. This is a good one. And this is what I keep telling you. Everything you learned, it will keep coming. So you have to be thorough with your old topics. Let's finish off. This is the last one for the day. I gave you a position vector. I'm telling you how the particle is going. Meaning, if you want a little more context, if I put t is 0, you're at origin. If I put t is equal to 1, you will be at half I cap plus 1 by 3 j cap. If I put t is equal to 2, 3, and so on, you can see the particle is moving. As the time changes, your position vector is changing. That is wrong, Anish. That is a trap, oh God. I'll tell you one thing. You see the word distance, have some fear. Anytime in the exam, you hear the word distance, right? There should be some fear like, ha, boss, let's be careful. Respect the word distance. Like, it's a scary thing. So, you will see in the next class also. I'll show you. Think distance can be, you'll get trapped. Like where Anish got trapped. Slok also got trapped. Suman also got trapped. If you are giving an answer in less than a minute, you got trapped. Maybe if you're in 12th and you got the answer in less than a minute, I can maybe understand. If you got it now, yeah, maybe you're a genius or maybe you got it wrong. Be careful. You're all calculating displacement. I didn't ask you displacement. I'll tell you what you guys are doing. T0, R bar was 0. At T is equal to 2 seconds, R final was 2 I cap plus 8 by 3 J cap. Right? So what you guys are doing? You are doing displacement, which is R final minus R initial, which is 2I plus 8 by 3 J. And you're finding the magnitude of this. Magnitude of displacement is a root over 2 square, that is 4 plus 64 by 9. That's 36 and that's 10 by 3 meters. What you got is displacement ka magnitude, isn't it? Nay, Karthik, that is wrong. This is not distance. I didn't ask you this. This is magnitude of displacement. You just took the initial and the final and you just finished it. Okay, a little more context. Nay, 14 by 3 is also wrong. Chalo, listen, I'll help you a little more to make you understand what's the difference between distance and displacement here. So we got t square by 2 I cap plus t cube by 3 j cap. Okay. So indirectly, this was your x coordinate and this was your y coordinate. Isn't that the meaning of your xi cap and yj cap, the position vector, right? So we have x is equal to t square by 2, y is equal to t cube by 3. So I can write t is equal to 2x whole power half. Take this guy and substitute here. You end up with 2x whole power 3 by 2 by 3. This is 2 power 3 by 2 by 3 and x power 3 by. This is also called as, equation of a trajectory, meaning equation of a path. The technical name, right, is a trajectory. Trajectory meaning path. Now, again, I didn't ask you all this, but I am giving a little context. So the path this particle is going is this equation. It's not going in a straight line. It is going in a curvy path. So this is the equation of the trajectory. If I try to draw this, so if I try to put this on a graph, yx, this is how the path would look like. It's some curve like this. Okay. At t0, you're here. At t is equal to 2 seconds, you're somewhere here. What I want you to find is this length, isn't it? This is going along the curve. This is your distance. What are you guys finding? From here to here, you are drawing a line and you're finding this. This is displacement. Is that making sense? The particle was actually going along this curve. So the length of that red line, red curve is the distance traveled, and the black line is the displacement. When you take initial minus or final minus initial, what you're getting is a line, isn't it? Now is the picture making sense? What is happening? Great. Now what? Nahi, Karthik, that is still wrong. And now go back. See, this is what you have to do. Always have to keep thinking. Okay, distance के लिए मेरे पास क्या formula है? I have only two formulas, right? Distance is mod VDT or distance is this. Now, in our equation, what is given? If you see, time is given, isn't it? So I should use this somehow. But to use this, I need velocity. How can I find velocity from here?
dr by dt.
By differentiating, isn't it? So I know my velocity. There, that's how it clicks. You should always ask, see, what do you mean by thinking? Tell me one thing. People say think. What do you mean by thinking? Thinking is nothing but whatever is being asked. You go back into the repository of your knowledge and you keep asking, okay, where did I see something similar? What all things do I know? Can I fit this? Can I fit this? Can I fit that? As simple as that. That's what you mean by thinking. The faster you do, the better you become better at it. So t square by 2 I cap and t cube by 3 j cap. Differentiate this. You get your velocity v bar dr by dt. That's your t I cap and t square j cap. Remember, I don't need this. What I want is speed. Because if I integrate v bar dt, again you'll get displacement. Speed is mod v bar, which is root over t square plus t power 4 or t into root over 1 plus t square. This is your speed, everyone. And now we want to find distance, which is integral mod v bar dt. So indirectly, you're asking me to integrate 1 plus t square t dt from 0 to 2 seconds. Are you guys with me so far? And this looks something similar, isn't it? Can you see how it looks? X का place में t था. This is what I was saying. This is how integration will pop up. No one will ask you the question directly. So how do we integrate this? We will say put 1 plus t square is equal to some z square. Differentiate 2t dt 2z dz. T dt becomes z dz. First, I will do everything in z and then I'll put the limits later on. So 1 plus t square becomes root z square. T dt becomes z dz. That becomes z square dz. That is z cube by 3. But z is nothing but 1 plus t square ka 3 by 2. Meaning, what is z? 1 plus t square whole cube by 3. Limits will go from 0 to 2. So that is 1 plus t square whole power 3 by 2 by 3. Limits 0 to 2. Substitute 2 first. That will become 5 power 3 by 2. Substitute 0. Then you get 1 power 3 by 2 by 3. That is 5 power 3 by 2 minus 1 by 3. That's your distance. So the length of this curve is this 5 power 3 by 2 minus 1 by 3. Is this clear, everyone? Now see, the question is not bigger. The question is actually only in this page, isn't it? I was just trying to tell you all the story here. Line ऐसा दिखेगा, ये displacement है. So it looks big. The question was actually, we did this only in one page. Is this making sense, everyone? Did you notice what I did? I showed vectors. I used differentiation. I used a distance. These are three different chapters. There, I used everything that I taught you. Yeah, you had to simplify it. So there, you saw all three things, isn't it? Differentiation, vectors, and integration, and yeah, kinematics. Questions would be like this. Any doubts on this? Got this? So next class when we catch up, we'll continue from here. We will do a few more on distance and then we'll go for slope method here. Yeah, you can do slope method also, it works. But इतना clearly time दिख रहे तो slope method क्यों use करना है ना? That was the thing there. So we didn't use it. Right. And then we will slowly go ahead. Like I said, in differentiation integration, we already did a lot of kinematics problems. So it would be easy for you guys. So please make sure to go through the entire, integration ka notes and kinematics, what we did. We'll continue on Wednesday again from here. So yeah, any doubts, anything else, please stay back and ask, or else you're free to leave. I'll see you guys on Wednesday, same time. So take care, stay safe.
Thank you, sir.
Yeah.
Thank you, sir.
Bye, Ray.
Thank you, sir.
Thank you.
Dhruv, got something? Dhruv? Dhruv, got something?